Very good morning, students. Myself, Vijay Lakshmi, working as Assistant Professor in ISL Engineering College. In the previous session, we have seen moving bed catalytic cracking and knocking. In knocking, we have seen octane number and secant number from Unit 4. Today, I'm going to explain you the last topic from Unit 4, that is the gaseous fuels. And along with that, we are going to see one numerical, that is about the Dulong's formula. And gaseous fuels are very, very important for the short answer questions. Maybe LPG, natural gas, or CNG. Among these three, one is compulsory question in the external examination for the short answer question. Gaseous fuels. The ease and flexibility of applications of gaseous fuels give them advantages over solid or liquid fuels. So because of the flexibility and because of various factors, the gaseous fuels are predominantly using than the solid and the liquid fuels. Gaseous fuels are having more applications and advantages than the solid and the liquid fuels. Let us see what are the advantages of the gaseous fuels. Combustion may be readily controlled, greater thermal efficiency, smoke and ash are eliminated, used in the internal combustion engines for the direct production of power. These are the advantages. And not only these advantages, we have various advantages of the gaseous fuels. But where we found the gaseous fuels? Same like the crude oil, same like the coal, even gaseous fuel also found in the earth crust. Along with the crude oil and the coal, we are getting the gaseous fuels in the earth crust. But not only from the nature, even we can get the gaseous fuels by treating of solid or the liquid fuels. That means by treating the solid and the liquid fuels, we can synthesize the gaseous fuels. So gaseous fuels are obtained either naturally or by the treatment of solid or the liquid fuels. Among the naturally occurring gaseous fuels, natural gas and liquefied petroleum gas are most important. So these are predominantly using, and natural gas and liquefied petroleum gas are very, very important in the gaseous fuels. And these are having high calorific value than the solid and the liquid fuels. So we know that solid fuels are having the least calorific value. You know what is mean by the calorific value? Calorific value is nothing but the amount of heat energy released when the fuel is burned completely. When a 1 gram or 1 volume of 1 ml of fuel is burned completely, that heat energy is called the calorific value. So the gaseous fuels are having more calorific value than the solid and the liquid fuels. So it is one of the best advantage and the best quality of the fuel. And the calorific value and specific gravity of a gaseous fuels determine the thermal output of a heating appliance. So let us compare gaseous fuels and the liquid fuels. Gaseous fuels are lower energy content than the liquid fuels such as petrol or the diesel. So these are consuming less amount of energy and these are lower energy content than the solid and the liquid fuels, especially compared to the liquid fuels. And gaseous fuels are potentially more desired fuel as they produce very low greenhouse gas upon burning, and hence air quality benefits are obtained compared to conventional and petrol and diesel products. So we know that almost all the liquid fuels are releasing more amount of pollutants in the environment. Those pollutants are the greenhouse gases. But whereas the gaseous fuels are releasing less amount of greenhouse gases, and these are benefiting the air quality. So these are the advantages over the liquid fuels, over especially petrol and the diesel. One of the best example of the liquid fuel, gaseous fuel is the liquefied petroleum gas. But why are we calling the LPG as the liquefied petroleum gas? Let us see now. But we know liquefied petroleum gas is also called as the cooking gas because which we are using in the domestic purpose, especially for the cooking. So whatever the cylinder we are using for the cooking purpose containing the LPG, that is liquefied petroleum gas. And liquefied petroleum gas is obtained as a byproduct during cracking of heavy oil or from the natural gas. So you know about the cracking process. What is the use of cracking? Cracking is using to synthesize the synthetic petrol or gasoline. Yes, so we are getting the petrol or gasoline by using cracking process. So cracking is nothing but decomposition of higher hydrocarbons to lower hydrocarbons. So what is the higher hydrocarbon here? Higher hydrocarbon is heavy oil. So this heavy oil is decomposing to gasoline. It is decomposing to gasoline. So gasoline or synthetic petrol is synthesizing by using heavy oil, by using cracking process. So along with the gasoline, we are getting CNG and LPG in the cracking process. But this LPG and CNG, these are removing from the outlet. Those are the uncondensed gases. So maybe you remembered the refining of petroleum. In the refining of petroleum, we have used the fractional distillation chamber. This fractional distillation chamber is having various steel plates, and along with this, it is having one of the outlet. In this steel plate, we are collecting the individual fractions. We are getting various liquid fuels in the refining of petroleum process. Not only in the refining of petroleum process, in the cracking process also, we are sending the vapors to the fractional distillation chamber. And these are the individual fractions outlet. But this outlet for the liquid fuel, But from this outlet, we are removing the gaseous fuels. One of the gaseous fuel is the LPG. So this LPG is forming as the byproduct in the cracking process. So how the LPG is obtained or how the LPG is synthesizing? LPG is obtained as the byproduct in the cracking process along with the gasoline. Or it is obtained from the natural gas. Even from the natural gas also, we are getting the LPG. And it contains hydrocarbons that are highly volatile. Yes, LPG is having some hydrocarbons. What are the hydrocarbons? Hydrocarbons are nothing but the compounds which are containing carbon and the hydrogen. Those are called the hydrocarbons. For example, methane, ethane, propane, butane, pentane. These are called the hydrocarbons. But whatever the hydrocarbons present in the liquefied petroleum gas, those are highly volatile. You know what is meant by highly volatile? Volatile is nothing but which can be evaporating easily. But here, these are easily liquefiable under high pressure. So these highly volatile hydrocarbons are easily converted to the liquid by applying pressure. So when we apply the pressure, when we apply high pressure on high volatile hydrocarbons, those hydrocarbons are converted to the liquid state. So the LPG is called as the liquefied petroleum gas because it is converts to liquid. It is easily liquefying under high pressure. But we need to maintain that pressure in the cylinders. So to maintain that only, we are storing LPG in the cylinders to maintain the pressures. And the components that form LPG are N-butane, isobutane, butylene, and propane with traces of propylene and ethane. So what are the hydrocarbons present in LPG? N-butane, isobutane, butylene, propane, propylene, and ethane. But here propylene and ethane, these are existing in the small quantity. In trace quantity, propylene and ethane are present. But the majorly contains butane, isobutane, butylene, and the propane. It is generally used as a domestic fuel for cooking and in the industry. So where we are using this LPG, especially in the domestic purpose for cooking and as well as in the industry also. Though it is cheaper fuel and knock resistance, yet it has limited uses as a motor fuel owing to its following disadvantages over gasoline. Yes, we know that LPG is cheaper compared to the remaining gaseous fuels and compared to the remaining liquid fuels, not liquid fuels, compared to the remaining gaseous fuels, LPG is cheaper. And one more, it is highly resistant to knocking. You know what is mean by the knocking? Yes. So it is cheaper and highly resistant to the knocking. But even though it is not used as a internal combustion in the motor fuels because of some drawbacks over gasoline. So let us see what are the disadvantages over gasoline. It has a faint odor and its leakage almost goes unnoticed. But in the domestic purpose, we can notice it. But whereas in the vehicles, we can't notice the leakage of the LPG in the motor vehicles. And pressure needs to be monitored for effective handling. Yes, for effective handling, we need to maintain the pressure. We need to store it. We need to maintain the pressure. We need to continuously monitor the pressure for effective handling. And it has a low octane number and high load sensitivity. What about the octane number of LPG? LPG octane number is very less. But for the good quality of fuel, for best quality of fuel, the octane number should be high. But the LPG is having low octane number and it is high load sensitivity. It can't bear more load, high load sensitivity. And it has high compression ratio. Compression ratio is more and less responsive towards blending, unlike power alcohol. So not like power alcohol. So it is highly sensitive and less responsive towards the blending. Yes, these are the drawbacks over gasoline. So because of these drawbacks, these disadvantages, LPG is not used as an internal combustion engine as a motor vehicle. And the next one, natural gas. Natural gas is one of the natural fuel which is found in the earth crust, same like the coal and the crude oil. Crude oil is nothing but the petroleum. The origin of natural gas is closely associated with that of petroleum. So similar to, that means almost the origin is same for the petrol and the natural gas. How we found the petroleum? The petroleum is found in the earth crust below the sea level. Same like petroleum, even natural gas also found in the earth crust. It is always found in or near the petroleum fields. So wherever petroleum fields are there, nearby that places only we can find the natural gas. So because of this fact, it is not available over large parts of our country, parts of the country. And although pipelines are being constantly extended to furnish gas to large consuming centers, where it may be used either alone or mixed with the artificial gases. And natural gas is a cheap and convenient fuel consisting of methane and other saturated hydrocarbons. Yes, natural gas is a cheap one and it is very, very convenient to use and it containing the methane as the major hydrocarbon And along with the methane, it is also having some saturated hydrocarbons. What is meant by the saturated hydrocarbons? The hydrocarbons which are having the single bond in it. And its calorific value is around 12,000 to 14,000 kilometers per kilocalorie per meter square. And this is the calorific value of the natural gas. And the composition of a natural gas is as follows. This is the composition of the natural gas. This composition is very, very important in the external examination. Methane is around 85%, ethane 8%, propane 4%, butane 1.5%, and hydrocarbons are 1.5%. So this is the composition of the hydrocarbons in the natural gas. So which is existing in the major portion. So methane is around 85%. And about 14% of the gas produced is used for making carbon black. It is also used as a fuel for industrial and is domestic constituent. And the last one, compressed natural gas. Compressed natural gas is similar to natural gas. So whatever the chemicals or whatever the hydrocarbons are present in the natural gas, the same hydrocarbons are present in the CNG also. CNG full form is compressed natural gas. Why we are calling compressed natural gas? Because we are compressing the natural gas. Compressing is nothing but applying pressure. By applying pressure on the natural gas, we are synthesizing compressed natural gas. This gaseous fuel is compressed natural gas, which mainly contains methane, same like natural gas. It is obtained by applying high pressure, generally 1000 atmosphere, to reduce the original volume at standard atmosphere pressure to less than 1%. So how much pressure we are applying? Around 1000 atmospheric pressure to reduce the original volume. So we are getting the compressed natural gas. So CNG is used as an automobile fuel, especially in the cars, and it increases progressively. Yes, so especially nowadays CNG is using in the automobiles. In almost all the vehicles, we are using CNG. And the best advantages or major advantages of CNG is it is a safer fuel since its ignition temperature is higher than conventional internal combustion engines, liquid fuels. Yes, ignition temperature is higher than the conventional internal combustion engines. And the next one, combustion of CNG produces lesser number of pollutants. Yeah, when CNG is undergo combustion, when CNG is burning, it is releasing less number of pollutants. So these are the advantages of CNG. But it has some disadvantages. Those disadvantages are it requires a lot of space for storage and hence it is not suitable for smaller vehicles. Yes, so we can't use in all the vehicles CNG because it is occupying more space. For storage purpose, it needs a more amount of space. Because of that reason, it can't use in the smaller vehicles. It has high ignition temperature that we have said. It is one of the advantage and also disadvantage. Because of high ignition temperature, it requires more amount of air for the ignition. For ignition, it requires more amount of air. These are the disadvantages of CNG. So that is about the gaseous fuels. And this is the last topic, which already we have seen in the first class of Unit 4, that is Dulong's formula. But today I'm going to explain you one numerical from Dulong's formula. But what is the use of Dulong's formula? Dulong's formula is using to find out high calorific value of the fuel. We can find out high calorific value by using mathematical expression. Dulong's formula is nothing but it is one of the mathematical expression. By using this mathematical expression, we can find out high calorific value or gross calorific value. According to Dulong's formula for the theoretical calculation of calorific value is high calorific value is equals to 1 by 100 into 8080 carbon plus 34,500 hydrogen minus O by 8 plus 2,240 sulfur kilocalorie per kilogram. So what is C, H, O and S? Here C, H, O and S are represents the percentage of the corresponding elements in the fuel. Yes, that means percentage of carbon, percentage of hydrogen, percentage of oxygen, percentage of sulfur in the fuel. It is based on the assumption that the calorific value of H and S are found to be 8,080, 34,500 and 2,240 kilocalorie when 1 kg of the fuel is burnt completely. So what are 8,080, 34,500 and 2,240 sulfur? Here these are the calorific values of these elements when 1 kg of coal is burnt completely. That means carbon calorific value is this, hydrogen and oxygen calorific value is this, sulfur calorific value is this. So by adding all these values, we can find out high calorific value. Yes. And however, all the oxygen in the fuel is assumed to be present in the combination with hydrogen in the ratio as 1:8 by weight. See here, 34,500 is the calorific value for both hydrogen and the oxygen. Yes, we can't tell that 34,500 is only the calorific value for hydrogen. By subtracting hydrogen with oxygen, we are getting this much of calorific value. So let us see how here. How the hydrogen and oxygen percentage, we know that it is in the ratio of 1:8 by 8. 1:8 by weight. What is the hydrogen atomic weight? It is around 2. So whereas oxygen is around 16. Yes. So 2 and 16. So when we divide this, we will get around 1:8 by weight. So the hydrogen available for combustion is H minus O by 8. The available hydrogen for the combustion is H minus O by 8. So when you add this, when you do this for the total of hydrogen and oxygen. So when you subtract hydrogen from the oxygen, when you subtract oxygen from the hydrogen, you will get around 34,500. That is the calorific value here. And that is the formula of high calorific value. This is the formula of high calorific value. So HCV or gross calorific value is equals to 1 by 100 into 8,080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur. So now this is another formula to calculate low calorific value. LCV is equals to HCV minus 9 by 100 into H into 587 kilocalorie per kilogram. Here 587 is the latent heat of water vapor, which already I explained you in the last class. Yes. So if you remember these two formulas, this formula and this formula, we can calculate high calorific value and low calorific value of the fuel. So now I'm giving one numerical to you to find out high calorific value and low calorific value or gross calorific value and net calorific value. Calculate the gross and net calorific values of the coal sample having the following composition. Carbon is 80%, hydrogen 7%, oxygen 3%, sulfur 3.5%, nitrogen 2.5%, and ash is 4.4%. But in our formula, in gross calorific value, we have carbon, hydrogen, oxygen, and the sulfur. Yes. So let us see the formula of Dulong's. GCV means gross calorific value is equals to 1 by 100 into 8,080 carbon. Here carbon is percentage plus 34,500 H minus O by 8 plus 2,240 sulfur. But in the place of all the elements, we mentioned the percentage here. But what is the percentage of carbon given in the numerical? 80, percentage of hydrogen 7, percentage of oxygen 3, percentage of sulfur is 3.5. So by substituting all these values, we are getting gross calorific value that is around 8,828 kilocalorie per kilogram. Now, in the next step, we need to calculate net calorific value. But what is the formula of net calorific value? Net calorific value is equals to gross calorific value minus 9 by 100 into H into 587. Already we have high calorific value. Then we can find out NCV. Already given hydrogen percentage also in the numerical. What is the percentage of hydrogen? 7. So see here, NCV is equals to HCV minus 9 by 100 means 0.09 into H into 587. So what is GCV we got here? GCV is 8,828 minus 0.09 into 7 into 587. So by simplifying this, we will get the net calorific value as 8,458.2 kilocalorie per kilogram. So this is about the calculation of high calorific value and low calorific value, or gross calorific value or net calorific value, by using Dulong's formula. So we have one more numerical left from unit 4 that I will explain you after completion of unit 5. Yes. So with this, we have completed unit 4. Thank you so much. Remaining we will see in the next one.